thank you for participating and thinking for a few minutes while we got set up and ready to go. I'm waiting for your attention now. Good morning again. We were talking, we hit just for a moment on what this is called compared to all of these. We just did all of these. We listed these expressions, and then I asked, what is something that's not an expression? And Alex, you gave me this. Why is this not an expression?
Because it has like an equal sign.
Oh.
It
has an equal sign. Okay. So an equation is just a sentence that shows that two expressions are equal. Did you notice that there are two expressions here? 1, 2. Did you notice that? So an equation is just a sentence that shows that two expressions are equal. That's what that is, an equation. So what I'd like to ask you now is if you can help me fill out this Venn diagram. You've done these before, I believe. I want you to tell me something that is alike and something that is different for expressions and equations. What is something that makes them alike, and what is something that makes them different? Jared.
Expressions don't have the equal sign.
Expressions, so where do you want to put that?
In expressions.
Expressions have no equal sign?
Yeah.
Like this? Does that make sense?
Yeah.
Okay. Lauren.
Expressions and equations require at least two numbers or variables.
Require at least two numbers or variables, okay? Good. Require two numbers or variables. Okay. Anything else you notice? Expressions. Oh, yes. Okay, so we have a word for that. To answer the problem is called solve. So for an equation, you would solve. And what is the word we use when you are working with expressions, when you're doing something with an expression? It begins with an E. Evaluate. Evaluate. Good. Evaluate. You evaluate expressions. And we solve equations. Are there any other differences or similarities? With expressions and equations, do they both involve operations of some kind?
Yes.
So they both have operations. And when I say operations, I mean add, subtract, multiply, divide. They both have some operation involved. How many expressions are involved in an equation?
Two.
Two or more? So this has two or more expressions? Or two? I guess it's just two. I'd say just two expressions. And this side over here, is there anything else we can put that's different? Does this have, do expressions have two parts to it? Expressions can have two parts, so we didn't have to put that there. Okay, now we're going to play a game, and this is a really competitive game. So, I need, for Team A, I would like these three boys. Would you come up here and be Team A? Really competitive. It's a competitive game. You'll just stand right up tall there, stand in a line. I need these three here to come up. I want this right here. This is a competitive game. Okay, well, actually, can both of you join this team too? Yeah. Oh, can you three right here, can you come join this team over here? Yeah, come on over here. Yes, three of you right here. This is really competitive, really competitive.
Let her do that. It's a huge team.
So, what did you say?
It's a huge team.
It's a huge, what's wrong with that?
That team is huge.
Oh.
Bristles.
Let's play tug of war.
Oh, okay, so can you sit down, please, and can, just, Jasmine, will you go
speaking.
It's helping.
Oh,
It's not fair.
Can two of you sit down then? Can you two sit down? Is that better?
A little bit.
Can all, except for the two girls, can all of you go over here?
That's still fair.
Can all of you, how's that? How does that work?
He's just like perfect. Perfect.
Okay, you guys
Actually,
sitting down
there's
still?
no fair.
Lily?
A bit.
Which side do you think you should join? Why?
Unfair.
Why?
Because they're better.
Because they're girls, maybe? Is that why?
No.
No, really, why do you think you should?
They have less.
They have less people. Jocelyn, the three of you, where should you go? Over this side? Oh, yeah. Then it would be unfair again. All right, thank you for helping prove my point. Very good.
Because they're good for charge. Because they're better.
So according to that game, the teams were not, what word might you use for that?
Even.
They were not equal. Oh, there's the math term. They were not balanced. They were not even. So we're going to talk a little bit today about balance and equations. We know that we have an equal sign in the middle of an equation. What do you think needs to happen on both sides then? Joshua, you were saying it well when we were up here. They need to be even. They need to balance. They need to balance. That's good. So if you will direct your attention back here to this. How you're going to get this chart. I have a variable. We talked about a variable. I have a variable here. Do you know what this variable represents? Do you know how much is in it right now? No, it's a variable, okay? So if I have an equation that is a variable plus 3 more, each one of these are 1, okay? This is new. Each one of these are 1. So if I have a variable and 3 more checker pieces, and on this side, I have 7 checker pieces. 1, 2, 3, 4, 5, 6, 7. But so right now, that is my equation, and it is balanced. So I'll even put this up there to help you see it. This is a bucket, or a variable, or n, we're going to call it a variable, the bucket, and 3 more. Equals 7, okay? So what's something I could do to keep a balance? If this actually was weighted, but it was balanced right now, what is something I might be able to do to this and keep it balanced? Jared?
Well, you could subtract 1 from n plus 3, and then also subtract 1 from the total.
So by subtracting, take them off, subtract them off.
Yeah.
Okay, is everybody okay with that? Yeah. So can I do that anymore? Is that all I could do to
No.
have I done everything I can?
No.
What else could I do? So I've got one of these on each side. What else could I do? Lauren, what else could I do? Can you see that okay?
Well, you could just keep doing the same thing.
Keep doing the same thing, what do you mean by that?
Like just taking both sides, so it'll just stay even.
Okay, so take another one, is that what you're saying? Take another one off? Okay, so how many have I taken off now from each side? 2, great. Elsie?
You can also add the same amount.
I could add, yes, I could add. If I want to find, you're right, if I want to find how much is in my bucket, though, my goal is to, and this is new for you, my goal is to get nothing else with it, so I can say my bucket equals however many are over here. Then I'll know how many are in the bucket. Okay. So, am I there yet? Do I know how many? Right now I have a bucket and 1 equals 1, 2, 3, 4, 5. So what do I need to do to find out how many are in my bucket? Jared?
You need to take 1 more off.
Take 1 more off. What was that like doing? If I really wanted to do it in 1 step, could I have done it in 1 step? Mm-hmm. What would I have done?
Taking off 3 from each side.
Lily, what would I have done? taken off 3 from each side, that's right. So I could take 1 at a time, but if I take 3 from both sides, my bucket is balanced now. And how many does my bucket have? 4. Okay, so if I had n plus 3 equals 7, that's what I did have, and I took 3 from both sides, what am I left with again? How many are in my bucket? 4. There are 4 in my bucket. So, does that make sense? Are there any questions so far? Let's see if you can help me do another one. Let's see if you can help me do x plus 1. Oops, I'm sorry, wrong one. N plus 5 equals 10. So n plus 5, think about, I want all of you to be thinking about what I would place up here to represent the equation. This is my equal sign. Did you see how I drew an equal sign right here? This is my equal sign. Can you guys move down some? Or Isaiah, move down some so you can see it? All right, so that much, n plus 5, and then we have a 10 here. A 10 is on this side. So maybe I'll put that there too. All right, so, how do I build this and figure this out? What do you think I should do? Jaslyn? I'm going to start with you, and then I'm going to ask Elsie to finish up. What's one thing I can do to my scale right here to build it? 10 on this side? Okay. 1, 2, 3, 4, 5, 6. Whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 here. What else can I do to build it, Elsie?
You can just take out wafers,
Put the bucket on. What does the bucket represent again?
the variable.
The variable. What we don't know what's inside, so we use a bucket, right? Okay.
And then you do put 5 checkers in.
Okay. 1, 2, 3. In the bucket or beside it? Beside it. 1, 2, 3, 4, 5. All right. Now, what can we do to find out how many checkers are in the bucket? Nicole?
You take 1 from each side.
Take 1 from each side? Okay. Alex?
You can take 4 from each side.
Take 4 more from each side? Is everybody okay with that? We could do 1 at a time, that's okay. But, or we could do 4 more. How many could we have done at the beginning? 5. So if I take 4 here, I need to take 4 from this side. How many are in the bucket? 5. Does it work? Is 5 in the bucket plus 5. Does that give you 10?
Yes.
So you found one way. We're going to talk about 2 different ways to solve problems, but before we do that, I want you to practice. So I'm going to give each one of you cups of checkers, and I'm going to write on the board 3 more examples that I want you to work on your side of the table. Get a marker and draw a balance. Well, I'll come around and draw the balance for you quickly. That way it's on the table. So the first one that you're going to work on is M plus 3 equals 9. This is the first one you're going to work on right here. The first equation you're going to work on. M plus 3 equals 9.
Yes.
That way we have 3 on the side. Here's your balance. What's your balance? M plus 3 equals 9. There's the balance. This is the little T standard. Balance. Can you see that okay?
Three. Which has question mark. Good mark. You can't see it, but it's there.
Please use your cup to represent what?
The bucket.
The bucket or the variable. The variable.
Oh, this
So we have question mark. And this, so we have to take three away.
I have extra here. If you need extra, you can come up to the table, check it out.
Okay. And we have 1, 2, 3. So there's 6 in there.
Remember, you don't need to put any in the bucket. The bucket is, because the bucket is full. I mean, the bucket, you can't see in the bucket, sorry.
You put a question mark on here, you can't see it there.
Can't see. Okay. So I think all the tables have finished. Raise your hand if you've finished. You still working on it? Okay. Ryan, your group is finished? Awesome. Okay. Do I have a group that will volunteer to do this problem for me? M+3 = 9 on this up here. So let's see. I'm waiting for all three hands. This group right here. Come back to the back of the table and describe what you did to do M+3 = 9. To solve for M+3 = 9. Please give your undivided attention to the ladies in front of the
Okay, so first, this represents the M, and it says +3. So you have to put 2 + 3. And then it says = 9. So you have to do 9. So, in able to find out how much is in the bucket, you have to take out 3. And the rest is 6. So, what's in the bucket is 6.
Does that make sense for the problem? Is 6 + 3 = 9 when you put 6 into the problem for M when you evaluate M?
Yes, indeed. Wrong.
All right. The next one I want you to try. Thank you, ladies. That was excellent. The next one I want you to try. The next equation that I want you to try is this one. 4 = x + 1. 4 = x + 1.
Okay, you guys gonna do this talking this
X, 4. Okay, wait, 1. The answer is 3.
Oh, we're getting fast at solving. Yeah.
5 seconds. And this is fun.
All right. Raise your hand if you're finished. Alex, is your group finished? Yep. Can I have your attention, please? 3, 2, All right, so we have, who can tell me what you did to solve this? Who can tell me what you did? What was the action that helped you solve this equation? What did you take away from each side of the equation, or add to each side of the equation to make it remain balanced? Lauren?
We all took away one.
You took
From
away
each
one.
side.
Okay, so you subtracted or took away one from each side. And that was enough? That left the bucket, Lily? That left the bucket by itself? So the bucket was
One.
how many?
3.
3, because you took away one, that's right. All right, now I have something different to show you up here. I think you've all got the addition. When you are looking at an equation that adds something to a variable, what do?
You add.
You subtract. So if I have, are you ready for this? You have to pay close attention to this one. If I have a bucket and I subtract 4 from the bucket, so let me remind you, I've taken 4 out of my bucket. I have 4 in my hand. This is a bucket, and I have 4 in my hand. And that is equal to, my equation is going to be equals 2. So we have 2 over here. How can I find out what's in my bucket? I have 4 of them in my hand. What should I do with those 4? What do you think? Right now it's a bucket with 4 missing equals 2. What can I do with the 4 that I've taken out? What do you think I should do to them? Isaiah, what do you think I should do to them? Put them back in the bucket, because right now there's 4 missing from my bucket, so I can't tell how many in the bucket. But if I put 4 in my bucket, what about, this is equal right now. A bucket with 4 missing is equal to 2. So what do I have to do? If I put 4, if I put 4 of these back in the bucket, how many of these do I need to put over here? 2. How many? If I put 4 in, what do I have to do on this side? I have to add 4. I'm putting 4 back in my bucket because they were missing. I don't know how many's in the bucket, except I have to put 4 more in. And I have to add 4 here. What does my bucket equal? 1, 2, 3, 4, 5, 6. My bucket equals 6. Are you ready to try one with me? I want you to think of how I'm going to set the bucket up. If I have x minus 3, how am I going to set this whole plan up? X minus 3 equals 6. You can set it up on your table if you'd like, and then we'll check it up here.
So there was minus 3 after 6. 6. 6. We need 6.
X makes
3. That was 6.
I see some good work going on.
Okay. So if there's 6, take away 3 and 6. I have not picked up 3. We can take away 3.
I have 6. And in my hand, I have 3.
She put 3 inside the thing. And 3. No, it said you had to add 3. No, we didn't.
3 back in the bucket. How long is that?
One more. And that would be 9. That would be 9.
Can I have your attention again?
Yes, 3. I don't know.
Thank you.
I just want the answer.
So Lauren, thank you for your table listening. And Bung, thank you that your table's listening. If I have a bucket, or tell me what I need to do here. Do I have it set up completely right now? Have I done everything I need to set this equation up as being equal? I've got a bucket that represents X. I heard a lot of you putting 6 over here, so you're good with that. But what do I have to have in my hand in this case? Nicole? 3. I have to have 3. Take it up. So I have 3 in my hand. What am I going to do? I've taken 3 out of the bucket. What am I going to do to put it back in the bucket? To fill up my bucket with what needs to be in there, I guess is the way I should say it. Yes?
Add 3.
Add 3. So I'm going to add 1. Whoops. Okay, I'm going to add 3 to the bucket, and then I'm going to add 3 over here, and that makes 9. So the bucket has how many in it?
3.
How many?
Oh, no.
9. That's 9. All right, so that's how you balance an equation. Tomorrow we'll talk about a second method on how to solve by what I call chunking. So that'll be interesting. Just to make sure we understand, you are making up teams that represent what an equation looks like. And think of teams in the front for me. Everybody get involved. Everybody make teams that are now balanced.
Okay, guys, now remember, it has to be even.
That's what she said.
Equal, even, same thing. Even is like this. Two of you need to get over here right now.
Do you have an even number of people in our class?
No, we don't.
Are we even now?
Look at you, you're on the girls' squad.
I'll stay at the ladies' bath. What? Yeah.
Do I need to be on this team?
That chair to
Yeah. Okay, we're even now.
So students, or do I need to be on this team? I'm confused. One more thing that I need to tell you. One more thing. I heard some people saying, make the teams even, and we use that a lot, don't we, on the playground. But even already has a math term, is already a math term. So we don't say that an equation is even because we have even numbers. We say that an equation is balanced if it looks like this, okay? So we use the term balanced. But you all did a very good job today. Your homework tonight, I want you to take out your agenda right now. I'm going to write one equation on the board, and you are going to write an email, a note to a friend, because your friend doesn't know how to use a balance to solve that problem. So you're going to tell that friend how to solve that problem. Students, I want you to sit down in 3, 2, 1. Raise your hand if you can tell me what you're supposed to be doing right now. Raise your hand. Lauren, what are we supposed to be doing right now? Students, I'm waiting because some of you are not listening. I need a repeat of what you're supposed to be doing. Lauren just said that you're supposed to be writing in your agenda. What are you supposed to be writing in your agenda? What do you write on the board? What I write on the board. Write a note. Someone asked, does it have to be an email? No. Just write a note or a letter or email type of a letter explaining to a friend how to solve, and here's your problem coming up. N plus 8 equals 13. You may do it on the computer if you'd like, but you also can handwrite your note. Are there any questions about the assignment? I'm looking for a detailed paragraph with some pictures of the scale. Tomorrow, it's due tomorrow, yes. Any other questions about what's due? As soon as you're done with your agenda, you may pack your bags and go to the next class.